So that's my Twitter, @allnersmile, my website, allnersmile.com. I've actually written a blog post on this talk, so if you ever want to, I'm not sure when these are going to get posted, but if you want to get started straight away, you can check that out as well. A couple days? OK. So it's a social conference, so feel free to jump on Facebook and like the page. It's PI on FB, and also Purely Imagine using the hashtag Win8PI. And this is the Twitter, or the hashtag for this session. So if you want to tweet, I don't think we have anyone answering questions right now, but I'll follow up after, and I can always address them at the end of this talk as well. OK, so most of this talk will be on sharing code between Windows 8 and Windows Phone using MVVM, and we'll be using XAML and C#. And the samples I'm going to show are trivial to get the point across. They're very simple. And so what I wanted to do is I actually wanted to start the session off with a real-world example, showing you how you can put these patterns and practices into use for your app, not just a simple sample app. And so in a minute, I'm going to invite some guys up from a partner to talk about how they've actually used these patterns and practices to implement a real customer app. And you'll be surprised which one it is, but it's actually really cool. And they've got it both running on Windows 8 and Windows Phone using MVVM. So before we get there, I kind of want to show a hand so I know who's in the audience. How many non-developers do we have here? One guy. That makes sense. Developer track, good. And he's actually one of the guest speakers, so that's all right. OK, how many XAML developers? OK. And how many HTML5 developers? All right, so I got a few HTML5 developers. And how many people have developed on Windows 8 and Windows Phone before? And how many people have never touched the platforms? OK, a few guys. OK. So I'll start with the real-world example. Then we'll kind of level set, make sure we're on the same page with motivations and benefits. Kind of simple, but we'll still cover it. I'll go over API convergence, and I'll talk more about that when we get there. And then I'll actually show you how to share code using MVVM and something called PCL. And then as a bonus for the HTML5 guys, the story on sharing code between Windows 8 and Windows Phone, HTML5 code and JavaScript, isn't the clearest. I want to spend a slide or two and show you a sample of what you can actually do and what you can't do, and we'll talk about the real story and the facts behind it. And then if we have time, just one slide on C++. I'm not a whiz in sharing code with C++, but I can talk about where you can use it and its benefits.
Is HTLM a new technology?
It is. Did I misspell that? Okay. See? Look at that. I'm getting heckled already. OK, so let's start with the real-world example. I'm going to invite Halogen Mobile to come down and talk to you guys for about 10 minutes on how they've actually used these patterns and practices in the real world for a real customer app, and they're getting paid to build these apps.
OK. Sweet. Morning, guys. How is everyone? Good? So I wanted to start. I wanted to start off by telling a little story about this 13-year-old kid, which is me, way back when I first discovered Windows NT. Does anyone remember that? Raise your hands. Yes? Does anyone remember 3D pinball? Yeah. Wasn't that awesome? So going with the whole pure imagination theme, I remember being a little kid and saying, one day I want to have Bill Gates as one of my customers. And it's really cool 13 years later that I get to say that Microsoft is one of our customers and that we're building apps for them. And it's all about taking real-life things and building great stuff on a great platform that just launched. So I'm one of the co-founders of Halogen. We design and build mobile apps. What we're known for is basically taking a mobile app and then finding brilliant ways to connect it to social and to web. So today we do that for companies like Microsoft, LG, AOL, and the Huffington Post, which we're here to talk to you about. Questrade, and even some great startups as well. So with the Huffington Post, we saw this great opportunity to take this really popular news platform and reimagine what that would look like on Windows 8. So to give a little bit of a framework, we didn't have an extremely large team. We're a team of 12, 5 developers, 3 designers, and the rest are strategy and business development people. And we had a month to do it in. So there might have been sleeping bags, there might have been long nights, but we were able to pull it off and build this amazing product, and it's now one of the top, I think, 10 news apps in the store. So I just wanted to show you how it's actually been executed. So part of the way that we launched the app was actually to take really popular locations and through signage be able to show the app, and you could actually move left and right and scroll through it and actually experience a Windows 8 app on this gigantic display. So it was a really great way to promote the platform, but at the same time show it with a real app that people are going to use. So that's pretty much all I have to talk about. I know Shell's got a lot more to share. He was our lead developer on the project and pulled off the entire thing within a month. So I'll pass it over.
Fancy stuff. Cool. Let me just clip this on. Hello, everyone. My name is Xiao. I'm a developer at Halogen Mobile, as Jason has introduced me. So what I'll do now for the next few minutes is I'll describe our experience in building a software for both platforms within the time frame of just about a month. And hopefully our experience will benefit you in terms of how you can exploit this new methodology that Honor will describe in a few minutes. Oh, wrong place. Oops. So when we got this project initially, what was going on in my mind, or in terms of where we're going to head towards, most likely is, we're thinking most likely we'll build on one platform, right, and then do some sort of a port onto the second platform. And the reason for that is because, we wouldn't want to build for great customer some sort of a cookie cutter experience where we have a very similar look on the two platforms. What we want to do is really have, first of all, offer a very high level of fidelity to the design paradigms of each UI, and also at the same time we want to offer a high level of customization on the UI to fit the brand. So in order to do that, chances are we wouldn't want to reuse some existing technology. We want to use something that's very native to the actual application. And then given a time frame, we were thinking, of course, we'll be able to reuse some of the code. We'll probably have one project, take some of the code out, copy paste it onto the other project, and reuse it in some way. But what we were not expecting is essentially having a single integrated project with a single build that goes onto two different platforms, right? Because if you think by experience, what usually happens with other platforms that we build for, I don't know, let's say we take a look at, we wanted to build an application on both Android and some sort of a desktop Java application, right? So yes, we can reuse some of the networking stuff. We might even be able to package all of that into a jar, and then have it linked to in two different projects, right? But once you start looking at, I don't know, if you were to use, let's say, Qt, and then you wanted to use stuff in the Android namespace, chances are there isn't that much stuff that you can reuse, right? And if we looked at, for instance, iOS and Mac OS 10, how many here are Apple developers? Oh, none. That's surprising. Okay, well, situation is a bit better, right? I drew a dashed line between, hopefully everyone's familiar with the MVC model, right? So I drew a dashed line across the view controllers. There is a way, if you structure it in a very careful way, that you can reuse a lot of the code. But again, it's not very complete, right? And if I'm going to show you a picture next, and this is what Honor will describe in his methodology, but essentially what we're able to do with the Windows platform is not only we reuse stuff like the networking, the data, all of that, but we were able to have a single view model, and all of that. So these two parts are packaged in the PCL project that Honor will describe later. So all of that is in a single product, and then combined with the two views targeting the two different platforms, all of that is in a single solution, right? So what that means is not only networking stuff, but also representation of the grid, which I will show you in the future, the templating. Now with the fonts, with the advertising, right, with translation, all of that is shared across the different platforms. So what that means is, so first of all, if you have to build in new features in the future, you have a single project, right, where you build all of it. There's a single build action. You don't have to create a separate project, build some DLL that you will link to, from your other two platform-specific projects, right? And also with Microsoft's very unique data binding system, what it means is also even more, even less code for you guys to link the view model to your views in the XAML. And ultimately, what this really means, as much for us and for you guys, is the amount of code, right? And if we looked at just the platform-specific project for the Windows Phone, it only represents 18% of the total code base that we have written for this entire project. So we're able to pump out support for new platform very quickly. And even if we looked at the 18%, maybe it doesn't do full justice to what we're able to build. So what I'll do is I'll go over the app itself, and then you can see for yourself how much difference this 18% can bring. So first, what I'll do is I will go over the desktop application, and then I will do the phone after. So here's our desktop. It adheres to live tiles and all of that stuff, right? So I will launch it off. And on the desktop side, what we do is we have this grid view system. Now it's a news article. It's a news reading application. So we loaded all the sections of the news. We adhere to things like semantic view, for instance. We also do, for instance, the snap view. Oh.
It might not be the resolution.
Yeah. It's, I think the projector, there's a minimum resolution that has to be supported in order to have two applications running at the same time. So I can't show you, unfortunately, but there's that, which is unique to the desktop, of course. If we were to look at all the articles of a particular section, and then we go into the actual specific article view. Now, remember this layout, and then we will go to the phone side. So let me just bring out the desktop. Oops. Oops. Yep. Okay, got it. Sure. Oh. No, it is unlocked. Oh, okay. Great. So now, if you look at the phone side, it's a slightly modified grid. And of course, to remind you, this entire grid system is actually in the view model, which is in the shared project, right? So what we have here is a slightly modified XAML code, but the actual representation of the data has been done on the generic project. So on this side, what we have is a different grid system. We also exploit the pivot view where as we swipe across the screen, we will then show the different sections. There is no full section mode because we can just scroll down. And there's the individual article page. So as you can see, in both cases, we use some very UI-specific design languages for each of the platform, while at the same time we have a minimum amount of code that's written for each. So hopefully your experience will benefit you, and then hopefully that this understanding of this new opportunity can give you give your company more possibilities in developing for more platforms in the future. Thank you.
Good? Okay, awesome. So thanks, guys. Really appreciate you guys coming in. So I just want to stress that one point, that 18% new code to port or to reuse, basically new code they need to use or write to get your Windows Phone 8 app. Sorry, your Windows Phone app. Sorry, your Windows 8 app onto your Windows Phone device. Too many acronyms, too many words. Okay, so let me stop this guy here and go back to the deck. Okay. Give me 2 seconds. All right, so motivations and benefits. Pretty straightforward. Really, what we're saying is that any code that can be shared should be shared. The advantage here is that obviously you guys are developers, you know this. Less code fragmentation. You have one source. You make changes in one place. It's less risk, and it also means easier development. In terms of the motivation and benefits, of course, you're going to code faster. You're going to get your app done faster. So what does that mean to you? Well, maybe if you're a developer and you're an entrepreneur, it means that less time working on the weekends, less time working at night, more times with friends and family. Or if you're actually working for a customer, you can pass that saving off to your customer. Get them out to market faster. Get them ahead of their competitors, show them the value in what you're offering. Or if you're sneaky, you basically charge them the same and you save more time. So it depends on what you want to do there, right? But really, it's about saving time, increasing your ROI, and client confidence and getting to the market faster. So I mentioned API convergence, and so I should say this talk is a level 200 talk, but we'll go to a level 300 level and then dial it back a little bit. There are a lot of terms kind of passed around like MVVM, MVC, model, view models, and models. I'll actually define all of those in case people here and people online don't know what that is, don't know what those patterns are. But to start the whole conversation, we need to talk about API convergence. And so if you've never built for Windows 8 before, you basically leverage a set of runtime APIs. They're called the Windows Runtime APIs. And whether you're building an app in XAML and C# or HTML5 and JavaScript, or even DirectX and C++, you leverage these APIs, and they provide capabilities and power to your application. Okay? In the phone world, you do something similar. Okay? So what we don't have right now is a one-to-one mapping of every API that's in Windows 8 available on Windows Phone 8. But we're on a path there, and I'll explain that in a second in the next slide. So in the Windows Phone world, if we go back in time and we go back to Windows Phone 7, what we basically provided was something called Silverlight for Windows Phone. And what that meant is that you could use XAML, a subset of Silverlight, and a bunch of .NET APIs that you coded in C# and VB, and you could build a Windows Phone app, Windows Phone 7 app, using those APIs. In the Windows Phone 8 world, you have those same APIs available. However, we've also introduced a new set called the Windows Phone Runtime. So this part can be a bit confusing, so I'm going to make sure I state it a few times. So in Windows 8, for Windows Store applications, you're building apps using the Windows Runtime. For Windows Phone 8 applications, you're building apps using the Windows Phone Runtime. And we don't have a one-to-one convergence there. But that's the path that we're on. And for completeness, you also have available to you a set of C++ and a set of DirectX APIs that you can leverage. So in a nutshell, on a very high level, this is kind of what's available to you on Windows Phone 8. On the left, you have your .NET APIs that allow you to do things like push and wallet and live tiles. And you use the .NET APIs. And in the center, you have your Windows Phone Runtime APIs. And those allow you to do things like geolocation and touch and proximity. And then on the right side, you have those DirectX APIs and the very low-level graphics and audio APIs. The one thing you may have heard us tout quite a bit is that the kernel between Windows Phone 8 and Windows 8 is the same. So that's kind of where we kind of have we're on that path to convergence, because we're starting at the lower level, and we have convergence there, and now we're going to start building up. So if you look at I think it's a Venn diagram, we have a ton of Windows Runtime APIs. Again, those are used to build Windows 8, Windows Store apps. And then we have a set of Windows Phone Runtime APIs to build Windows Phone 8 apps. We do have an intersection. And so you can see here that we have networking, proximity, file system. They're all the same. So you would write code once for Windows 8, and you'd be able to reuse that code for Windows Phone 8. Okay? Some APIs, like on the phone, like VoIP, or I think we have a speech, they don't really make sense in the Windows 8 world right now, so they're not available there. They're only available to you on the phone. Okay, so let's talk about sharing code with MVVM. I'm going to jump into a sample first to kind of show you what we're trying to achieve, and I'll walk you kind of through some of the code as well as I'm explaining the different parts of the MVVM pattern. Let me just check. OK, so first, I'll define what MVVM is. This was an architectural pattern created by John Gosman, a principal architect at Microsoft, who I worked with when I was there for XAML for Windows 8. And it's a derivation, or it comes from MVC, which is another pattern. Essentially, MVVM really works well for any XAML-based technology because you leverage a set of features that only really XAML has, and that's that really powerful data binding. And you'll see some examples of that in my sample, but data binding on its own is an entirely, like another probably 3 talks. There's tons you can do with data binding, and it's very, very powerful. So why MVVM? Why use it? Well, besides the fact that we know that it's going to help us share code, it also allows us to loosely couple our UI and our code, our UI and our app logic. So what we can do is have a tier structure where we can basically reuse core components of our application. And in terms of a process, if you have a company and you've got developers and designers, You know, back in the day, if your designer or your developer is working on something, you threw it over the fence to your designer. If they changed, you know, an ID or they removed an element, well, if they removed an element, it's still trouble. But if they changed an ID or they, you know, move things around, it could cause potential problems where you hit F5, it's not going to compile. With MVVM, what you're doing is just throwing the view over. They're going to data bind to the set of properties that your designer and developer have kind of communicated on, and you're able to basically make sure that when you hit F5, it's going to compile. No matter what happens in that view, it doesn't affect the actual app logic and the core code. There's also increased testability, which I won't talk about here, but there's plenty of information online about how you can test MVVM. So let me jump to the first example, and I believe that's this one here. So I'm going to run the app real quick, and as I mentioned, it's pretty trivial. What it does basically is pull down box art or cover art from the Netflix OData API. So this is a Windows 8 application using those Windows runtime APIs. And again, you can basically pan through the list. It's pulling down around 100 titles asynchronously. Okay? So let me close this guy down. And I'll switch back to the deck. Okay, so in that MVVM pattern, you've got three things. You've got a model, a view model, and a view. So first, the model is basically the lowest level, if you think of it as a layer cake. Your model is really where all your data and your business logic goes. And that's really things like, data could be from a database. It could be a web service, like in my example, it's OData from Netflix. It could be a file system, anything like that. That's where you throw that data. So in my sample, I'm going to do some, see if I can get this. Okay. I have to keep closing the slide down. Okay. So in my sample, I'll show you the model. As I mentioned, I'm pulling down data from Netflix using their OData API. And so what I've got here is basically a class that describes what comes down as a title. So a title from Netflix is an ID. Can everyone see that okay at the back? Do you want me to zoom in? It's okay? Okay. So it's basically like an ID, a name. It's got a rating, release year, and it has something called a box art. So if we dive into box art, I've got another class that defines what box art is. And the reason I have these data members and these data contracts is that at some point, I'm going to serialize the JSON data I get from Netflix into this object model. So that's my model, basically, right? This is what my data is going to look like when I grab it from Netflix. And that's all there is to it, basically. It's just really just the structure of the data. So let's jump back to the slides. OK, so a view model builds on top. So we have the model at the bottom. The view model is next. And that basically is a specialization of the model that the view uses. And I'll talk about what that specialization word means. But essentially, what you're doing here is you are providing something in the middle of your data and your UI to kind of glue them together. It's the plumbing, really. And really, the whole point of the view model is that it informs the view to update, again, using some XAML constructs that I'll briefly touch on. And the view model has no UI code, absolutely nothing, right? So in my sample, I'll show you again what that looks like. So here, first, I have my view model. I've got a reference to the model in my project, so my view model uses the model. And I've got something called title view model. And what this basically does is it just exposes a property called titles right here. And so when actually, I'll go into it step by step. But basically, I expose something called titles. And if you look at title art, it's actually just one property called box art. Because my sample is really simple, right? All I'm doing is showing you the cover art, no ID, no name, no rating. So what have I done? I've specialized the model for the view, right? So now I only have a very simple view model, even though my model may be really complex. So if we go back to the view model, you can see here that I call, when I construct this view model, I do something called getTitles. Whoops. It makes a call to something called a query, and that's just some code I've written that we'll explore later in another sample. Pulls down the titles, and then throws them into my observable collection. And the observable collection is basically how the view knows to update. So that's part of that data binding magic that I won't really go into too much detail on. So that's the view model. Next up is the view. So I'll switch back. Okay, so the view, pretty straightforward. It represents your UI code. Every page in your app would have its own view. It could also have its own view model. It's really up to you. The goal of the view is really to have no code. The goal of the view model was to have no UI code. The goal of the view is to have no app logic code. You need a small amount, but really not too much. So again, let me show you what that looks like in my sample. So here you go. I have my Windows 8 application. I have a reference to the view model. You notice that there's no model in here, right? I haven't referenced the model, but only referenced the view model, because that's that separation. Oops. And I'll go into the actual XAML. And so if you see down here, what I've basically done is I've got a grid view that is binding to something called titles. And if we jump back to the view model, you'll notice that my property was called titles. So keep that in the back of your head for a second. And then I define an item template, and really it's just an image, and I'm binding to box art. So as you can see, what I'm doing is I'm grabbing the view model, I'm accessing the property called titles, and then I'm actually dot notationing into that object to get the property, which is box art. And I'll just F12 that, which is this guy right here. So the code to actually wire that up is basically it's one line of code. It can be one line of code. What I'm doing is I'm creating my new title view model, and I'm setting the page's data context to the view model. So what I've done is said, hey, view, this is the information you're going to reference. It's this view model. And then my controls dive into that view model, pull out the property it wants, or the object that it wants, and then dives into that object and gets the actual property itself, which is the box art. And that's all there is to it. So that's how the MVVM kind of works out in a very simple and perfect world. So let me jump back to the deck. Okay, so MVVM by itself is great for separating the UI from the view and reusing your code if you're on the same platform. So if I had another Windows 8 application, Windows Store app, I could reuse my view model because I have code in there that runs on Windows 8, right? I'm calling APIs. Basically, I'm calling a networking stack HTTP client that's on Windows 8. But when I bring that code over to the phone, it's not going to work because that code isn't available on the phone. And if you remember that API convergence diagram, there's only a set of APIs that are portable, or common, sorry, and a set that is portable. So it doesn't really help us when we're trying to share code with the phone. But you can use something called PCL, which is Portable Class Library, and that actually does allow you to share code between both the phone and Windows 8. So the PCL, when you create it, you actually get something like this right here, this dialog, that asks you what frameworks you want to target. And you can see you don't have to just do this with Windows 8 and Windows Phone. You can even target Xbox. You can target Silverlight. You can target a bunch of different versions here. So in my sample, I've just said, hey, Windows Phone 8 and .NET for Windows Store apps, because that's what I'm focusing on. And by default, it pulls in the .NET Framework 4.5, because that's the core set of APIs. So when you create this new project and you compile, you get a single assembly, single DLL, that you can actually import or reference in your in your Windows Phone 8 application and your Windows 8 application. So I think that covers everything with PCL. The other cool thing about PCL actually is that when you are coding it, you'll actually only be able to, IntelliSense actually stops you from referencing any API that is not portable. So it's a subset of APIs that run on both platforms. Okay. So sharing code with MVVM and PCL. I want to give you a visual on what this is actually going to look like. And so as you see here, we've got two apps, a Windows Store app and a Windows Phone app. The Windows Store has its own view, and the Windows Phone app has its own view. And you saw that from Halogen when they presented. He was talking about how each app has its own platform-specific view, using platform-specific controls, right? And that makes sense. But then both these apps are referencing something in the PCL. They're referencing a view model and a model. So now we've got both apps referencing common code or portable code, right? And so based on that, it looks great, right? But there's one thing I haven't mentioned, one pretty big wrench in all of this. And that's that gray box at the bottom of each of these bigger boxes, that it's platform functionality. So I mentioned that we don't have convergence. So what happens when you want to call an API that's not available, when you call an API on Windows Phone, Windows Phone 8 that's not available on Windows 8? Well, things are going to blow up, right? Because it's not going to compile. So what you have to do actually is use an abstraction pattern. You have to define interfaces and then implement those in a platform-specific way. And I'll actually show you examples of this. So let's see. OK, so let's actually go into this now. So we're done with this guy. And we're done with that guy. OK, so you can kind of see the same project structure. I've got the model, the view model, and I had my Windows Phone 8 app. I've changed things now because I've introduced the Windows Phone 8 application. So I'm going to run this just to prove that it does work. And here you see, I've got, again, a very bare bones application, but it does the exact same thing. It's listing all the titles and the box art, right? You're supposed to clap for that, Matt. Thank you. Yeah, that's right. OK, so let's take a look at what's going on here. So the model hasn't changed. It's the exact same model that you saw before. We've got the title. That's the structure that's going to come back from JSON. And we've got the box art. Nothing's changed there. But we have changed the view model, because the view model in the last project I showed you was very Windows 8 specific, and it wasn't using any abstraction patterns. So if we look at the view model now, you notice that we still have this property called titles, but we've kind of changed the constructor a little bit. So we've got the view model is now taking something called an iGetTitle service. And then it's using that to call a method called getTitles. And then it's kind of doing something similar where it's loading up the titles. And I'll talk about this little conditional compilation at the end. But essentially what we're doing is we're creating a new view model. We're passing in a iGetTitle service. And then it's going and actually making the calls. So in the Windows 8 world, you use an API called HTTP client to make web requests. In the phone world, you use the HTTP web request to make those same calls. So again, we don't have API convergence. It's two different sets of APIs, but they're doing something fundamental for my app, so I have no way of working around that. They need to hit the network. They need to use those APIs in a platform-specific way. So if I look at my iGetTitle service, all it's doing is defining, it's really just an interface, right? That's all it is. It's defining something called getTitles that returns a callback that accepts a list of titles. So a callback is really just a function. It's a function pointer that takes a list of titles. So that's great, but we need to actually now implement that interface. So if I scroll up, you'll see that I have something called a phone service and a store app service. So the store app service really isn't changed from the other sample, except now that it implements the iGetTitle service, and it has something called, getTitles. That passes back a callback, that takes a callback that accepts a list of titles, okay? So what I'm doing here is I'm basically going to invoke getTitles. It's going to do it the Windows 8 way, which is doing things asynchronously using the async and await keywords. So it goes and calls this guy right here, which is basically just setting up a query, creating a Netflix URL to go get the right data, and then it's going to actually serialize that or deserialize that into my object structure. So I'm getting that JSON data, and I'm now putting it into an actual object model. Okay? If we look at the phone service, it's got a very similar structure. It's still implementing iGetTitle service. It still has this getTitles that takes a callback that returns a list of titles. But it's doing things a little bit differently. So it's still doing the serialization the same, but down here you'll see that we've got a whole different set of code. And that's the Windows Phone 8 code that needs to go and hit the network. So a whole different set of APIs, HTTP web request versus the Windows 8 HTTP client. Okay? All right, so again, just to kind of reiterate what's going on there, my view model takes an interface. It's the iGetTitles interface. It doesn't care on the implementation. All it cares about is that it has this getTitles that can be called. And then I've got two other projects that implement that interface in the platform-specific way. Now, if I jump to my actual Windows Phone 8 application, you'll see that I have a reference to the view model. That makes sense. But also the phone service, because that's the platform-specific functionality. And in my main page, nothing changes in the UI. The only difference here is that I have to pass it a new query. And that query is, we have 12, that guy, is that platform-specific implementation of iGetTitle services. So now the view model doesn't care what it's actually calling. All it knows is that it's going to call something. And when it runs on the phone, it's going to be calling the phone implementation. But my view model is shared across both platforms. And the same thing in Windows 8. It's creating a new query, but that is going to be the Windows 8 version. And you can see that using the HTTP client. Okay? Does that make sense to everyone? I'm seeing nod heads. Yeah? Cool. OK. So there's still one more wrench that I haven't talked about. Well, there's a couple wrenches. The first is that in Windows 8, things are done asynchronously. And you're able to, and the platform actually takes care of marshalling calls from one thread to the other thread. But on Windows Phone, you still have to control that yourself. So you need to get access to something called a dispatcher. And the dispatcher runs on the UI thread. So when you're doing an asynchronous call on the background thread, in Windows 8, you don't have to worry about it. The platform is going to take care of it for you and call it on the UI thread. In Windows Phone, you have to do that yourself. So what I've done here is if you notice, I've also got something in my view model called an iDispatch. And it's really just abstracting the dispatcher concept to prove a point. And that is that in the view model, I now take both, where is it? The title service and an iDispatch. And when I create my view model, when I create it in the actual apps themselves, I'm going to be passing in a new phone dispatcher. And I won't spend too much time on this, but essentially it's the same pattern, right? I've just created an interface, and I've implemented it right here. Actually, I can just go F12, and I'll be faster. And it's just basically calling the phone dispatcher. That's all it's doing, right? You have a question?
Question, yeah.
Uh-oh.
Just to clarify.
Yeah.
To use phone dispatcher, so I know that there's some APIs that have the async model
Yep.
in Windows Phone 8. So just to clarify, we only have to use the dispatcher for APIs that don't overlap, that don't, like web client doesn't have
Right.
async call.
Exactly. Exactly. Yeah. Good clarification.
Thank you.
That's the Windows Phone champ right there, keeping me in check. OK. So essentially, though, the point here is it's the exact same pattern. I have a concept I need to abstract, and I've done that. And actually, in Windows 8, you'll notice when I pass in the view model, where is it here? I'm passing in null, because for Windows Phone, Windows 8, there's too many Windows things here. So for Windows 8, it's taken care of for me, right? OK, so that's one wrench. I mentioned the conditional compilation. Because of that dispatcher code, in Windows Phone, I have to actually call that dispatcher construct. And that's what I'm doing here. But in Windows 8, I can just do it regularly, right? So this is my view model code. I want to keep it portable. I don't want to have to create two view models just because of this one difference. So I've used conditional compilation, and some MSDN articles out there you can reference. But really, it's just checking a build time flag. And you can see up here, I've got Windows Phone. And that's what it's doing, basically. So when I compile on Windows Phone, I set that flag, and it's taking care for me. OK, so let's go back to the slides. OK. OK, so we talked about how to share the view model and the model. What about the UI? Can you share the UI? Well, really, your UI should take advantage of the form factor. An app on Windows 8 should feel and look different than an app on Windows Phone 8. There are also a new set of controls, and Shao kind of mentioned that when he was talking about their Huffington Post UI. In Windows 8, you're using the grid view. In Windows Phone 8, you use something called the long list view or long list selector, one of those. But it's basically a control that is built for that platform, for that form factor. Now, with that said, XAML is still XAML. So when you create things like images and buttons and stack panels and grids and checkboxes, they exist on both platforms, right? So what you can do really is you can use a control to take advantage of the form factor, But your item templates, you can always reuse those. You can always reuse pieces of your code. It's more worthwhile to do copy and paste than spending too much time trying to actually really share a view like you share the view model or the model. It's really just not worth the time investment. OK, so let's do a sharing recap. How am I for time, guys? Half an hour? OK. So recap. What to share, how to share. The view, don't waste too much time trying to share that. It's platform specific. It should be. You want a great experience on both platforms. And HuffPost really kind of showed what that should feel and look like, right? Now, the view data binds to the view model. I showed you that code, setting the data source on the page, on the view. The view model and the model, definitely, they can be shared. But there's one wrench that I haven't mentioned yet, and there's a difference between what's portable and what's common. A portable class library can only contain portable code. And really, those are the .NET APIs. So if you look at my view model, I won't switch back, but I had a lot of just core types, basic types, right? Nothing too advanced. I didn't really use any Windows runtime APIs or any Windows Phone runtime APIs because they're not portable, they're common. So now you're probably thinking, like, what's going on here, right? So how do you share your common code, which is your Windows runtime APIs and your Windows Phone runtime APIs that are one-to-one map? Well, you would create a new project, and you'd have your code that calls these APIs, and you'd basically link to it in your project. When you add a project reference, you can go down and say link to. That means that you'll basically have one place where you make those changes, and when you build, it'll link those projects in. So to recap, what you're basically doing is you're going to have a project that has a view model and a model using PCL, and you're going to not have any runtime, Windows runtime and Windows Phone runtime APIs in either of those classes. Then you're going to have another project that contains those runtime APIs. Just one, because they're common, basically, right? The reason for this is because portable code can be compiled on any platform and run on any platform. Common code, which is these runtime APIs, have to be compiled on the platform it's targeting. So you still get to share the code. It's just one extra little step you have to do in kind of separating that code out. Does that make sense? Yeah, cool. OK, so here's the bonus. Sharing HTML5 and JavaScript. I will start with a real-world example. So I'm going to go to a Disney app called Agent P Strikes Back. I'm going to go ahead and do this. So I don't work really much Disney, but I'm assuming this is a show of theirs, and you can basically do pretty cool things. You can run around, you can have some fun. It's all HTML5 and JavaScript, and it's running natively on Windows 8. Okay? So let me get out of this. So remember that, and now let's go look at the exact same thing running on Windows Phone. Whoops. I think I have to rotate this. I'll tell you the secret later. OK, the exact same experience, the exact same game. And actually, I'm going to have to play with the touchscreen here. But actually, it's the exact same code. OK, so you got the app, an HTML5 JavaScript app running in Windows 8 and running on Windows Phone 8. So how do we get that experience? Well, let's go back to the slide deck. Let me see where I'm going here. OK. So here's the guidance. When you build a native HTML5 JavaScript application for Windows 8, you're leveraging those Windows runtime APIs, and you're using something called WinJS. That's Microsoft's JavaScript library that provides to you controls, animations, a bunch of things that your Windows 8 store app needs. Okay? You cannot port or share code from an HTML5 JavaScript Windows store app that uses the Windows runtime in WinJS to Windows Phone 8. Now, I just showed you something where you saw that it was the same code running on both platforms, but it was not an app that uses Windows runtime APIs or WinJS. Okay? If you have an HTML5 JavaScript website, you can share that HTML5 and JavaScript with Windows Phone 8. Okay? So basically what you're doing, and I'll show you an example in a second, is you are loading up the website or that code in a, what do we call it on the phone? The web view? Web view, right? A web view control, which is basically punching a hole and saying, hey, go load some HTML content and JavaScript content. And it uses the IE10 rendering engine. Okay? Now, that doesn't mean that you can't invoke native code. So if I'm on Windows Phone 8 and I press a button and I want something to happen on, I actually want to call a Windows runtime API. Let's say I want to launch the camera launcher. I want to do something that's native. You can actually do that. But there's a way of doing it. So I'm going to show you that right now. So the first thing I'll do is I'll show you the code I ripped off. So this is from the IE test drive site. It's just a calculator. It's HTML5 and JavaScript just to kind of show it's a sample. So what I did is I basically brought up developer tools. I ripped everything, changed a few things here and there, but let me bring it up here. Put this the right way. So basically, let me clear this out. Right? So it's the exact same experience. It's the exact same code. The only change I made to make a point here is that it detects prime numbers. Where'd it go? Let me do that again. Pardon? Alt? Oh, is it going to give me the app though? No. I'll just stop and restart it. Okay, so the only difference here is that I'm actually calling some code on well, it's not native code, but it's code that's in a code behind file that detects prime numbers. Okay, so that is actually showing up in a message box that is a Windows Phone control. So let me show you what's going on behind the scenes. So what I'm doing is I've got a main page in XAML. Oops. If I can get my mouse. There we go. Okay, I've got a main page of XAML, and all it's actually doing is it's got something called where is it? Up here. Oh, it's the web browser. So it's got a phone web browser, and it's just basically doing some layout and setting something called script notify. And that's the magic in all this, and I'll get to that in a second. So if I go to mainpage.cs, I'm basically loading up, or I'm navigating to an HTML file called index.html, and that's over here. Right? And this is literally just copied and pasted from developer tools. And I think in the CS you can actually see that? Oh, I think I removed it. So basically, it's this, I took the style sheets, the JavaScript. I put a reference if I'm doing using the CDN for jQuery, and my web browser is loading that up. Okay. So to actually invoke that platform code, let me close all this down. I set something called script notify. And in script notify, I'll show you the code in a second, but basically I'm calling an API that will invoke this code, and it's basically calling this code here, right? So that is, and I'm going to breakpoint it for you just so I can prove the point. So 11 is a prime number, right? So it's hitting this code, and it's doing it. Okay, and the only line of JavaScript I changed, and hopefully I can find it, is, I think it's Windows. No, it's here somewhere. Is it script notify? Do you know what it's called? The API? All right, it's here somewhere. Hold on. Can't remember where I put the code to actually call it. Set item. Oh, right here. So Windows external.notify. And I'm basically passing in a variable, and that was the integer that you saw, the string that you saw, which was right here, e.value. That's what gets passed. And that's it. So I'm able to invoke code that's in a C# file in a Windows Phone 8 application that is using HTML5 and JavaScript, right? But there's obviously those limitations around it, where you can't port code that uses the Windows Runtime APIs or WinJS, but you can bring in your code from your websites, from other applications you've built that are purely HTML5 and JavaScript, and you can kind of get it to work together. So there is a reusability story there. So the last thing was around C++. Let me come back to the deck. Time check?
You have 15 minutes.
OK. So I'll take questions. Oh, whoops. OK. That includes Q&A?
Yeah.
All right. Let's go here. OK, sharing C++. So I have not done this myself. This is guidance that I've gotten from elsewhere. Of course, if you're building a Windows 8 application using C++ and DirectX, that code can be shared with Windows Phone 8. I'm not sure if it's as easy as doing the MVVM model, because I haven't done it myself. But definitely C++ code and DirectX, it's the same stack on Windows Phone 8. You can bring that over. You can port that code. Any iOS, there weren't any iOS developers here, right? Except one guy at the back, I think. You can build C++ libraries and then run those on other operating systems. There are also other toolkits out there. There used to be one called Mono, but I think it's changed its name now. I don't know what it's called anymore. But if you do a search for Mono, you'll see that someone's actually built a toolkit that lets you build apps that are cross-platform using C++ and using these tools. So that's that guidance. Session eval, this is a legal slide, I think, that we're not collecting any personal information about you. Yes. And your feedback matters, so let me know how I did, if I sucked or if I was all right. And that's the link at the bottom there that hopefully you can see on that screen over there. And I'll leave that up just so you can grab it. But any questions? Go for it. Do we have a mic?
No, just repeat it.
OK. So you can, so yes, so the answer is yes, you can use the same pattern. If you go back to that, if you think back to that slide with PCLs where it showed what frameworks you can select, you'll be able to select the .NET framework, and you can kind of pick the right platforms that you want to target. It's not going to be as fruitful as doing it from what I've shown, basically, because there'll be a stricter limitation on what APIs you can use. It's like targeting, if I select Xbox there as well, on that dialog, it would again shrink the set of APIs that I can actually leverage. So,
like there's a view model, right?
Yep.
You can use a view model for both.
So I haven't done it myself. The pattern stands for itself. You can create a view model. How valuable it's going to be for you and how many wrenches are going to be kind of get thrown up really depends on what you're doing in it. So I can't really speak to a personal experience, but you can use the pattern definitely to create a view model that is shared.
Yeah, and also the portable class library, if you notice from the screenshot, you can actually include the .NET framework as part of that. So that would be your traditional desktop application, and WinRT would be whatever the Windows 6.
Yeah. So again, it's going to just allow you to access APIs that are available in both places, and so it's going to be a smaller subset of APIs. Cool? Question? Yep.
I'm developing like a book app along the lines that Paul used. I think it's called list view data binding in a lab yesterday. And obviously I've used HTML and JavaScript. How am I going to be able to port that to the phone?
So I haven't seen that. So the question was, I don't know how to repeat that question.
The list view, like the actual list view control you're talking about, how you can bring that over to the phone? Well, no, like, you know the way you showed us in the lab yesterday on how you display the various components, okay? And in the tablet or Windows 8 application, it went across the several screens.
Right.
And am I wrong in taking that approach if I want it also to be as a Windows phone app?
So
That's actually a little bit different than the code sharing in the background, right? So
that sounds like the view, right? We're trying to share the view.
The UI constructs, although they're similar in Windows 8 and Windows Phone, are implemented differently.
Right.
Right.
So there's no grid view on Windows Phone 8, where there is a grid view in Windows 8. However, your item template is most likely you can copy and paste that in because it's going to be stack panels and buttons and images, right?
It's all XAML, it's just slightly different constructs. So again, that's your view sign. So that's the point in Ulmer's presentation where he showed that's the point where it kind of deviates quite a bit.
Right.
The good news is it doesn't deviate a lot. In fact, I've seen Ulmer do the talk where he changes like one line of code in the view and it works.
And again, that's for it's for a simple example, right? So in your case, you could probably change the grid view to a list view, and you would probably see that it would compile with a few other tweaks of the XAML here and there. But for a complicated, non-trivial example, the view really should be different. And you should think about it that way as well, because you want the best experience on the form factor.
There's also things in the view that's not supported on phone, things like snap view and stuff like
right.
that that's not necessarily supported on phone, so you want to be able to differentiate that.
Okay,
Yeah.
thank you.
Question?
When you create observables and you make changes on the view, are the changes reflected back on the model?
Okay, so that's a data binding question. I'll repeat it for everyone that's at home. For an observable collection, if you make changes in the view, do they get shown back in the view model and the model? The answer is yes. You would set something called it's two-way binding, basically. So it's called two-way binding. And when you make a change in your view model will pick that up, and it's up to the view model to update the actual model, the database or whatnot. And that's a data binding question, so there's plenty of stuff online on that as well. Yeah, question?
Does Windows Phone 8 support the ADO.NET?
Does Windows Phone 8 support ADO.NET? So ADO.NET was renamed to something else recently, wasn't it? It's the new, pardon? No, so I think you're talking about just data sets and those types of things? Yeah, so I haven't seen data sets on Windows Phone 8, but I think they are supported, aren't they?
I think so, but
I think it's going to be a subset again of the APIs, but it's a good question. I'll have to check offline, and I can get back to you offline. I'm not too sure if the whole ADO.NET API is supported. Okay? Any other questions?
just a comment
Yeah.
on that. I mean, at the end of the day, there's a lot of APIs, and I don't know off the top of my head what data APIs are available, but you've got a lot of APIs that do different things, from accessing data from the web, accessing local storage data, accessing kind of SQLite stuff or whatever. So, I don't know a scenario where you would need full-blown ADO.NET on a phone-specific app, because you're not, that would be very heavy for a smaller kind of lightweight app.
And do you know about the object browser in Visual Studio? So I would just do the query there, get the right browser right frameworks, the right platforms, and just see if your APIs are available right now, like data sets, and those are things you're worried about, right? Because you have a model defined previously that you want to pull over. Is that the scenario?
ADO.NET RESTful services APIs are supported within Windows Phone, I'm pretty sure. So I don't know if that means ADO.NET proper is fully supported within Windows Phone, but a good portion of it probably is.
Cool. Okay, any other questions? Yeah, at the back.
For this new actor, is that can we just create a new project directly in Visual Studio 2012?
These model, view model, and so the model and view model are PCL projects, and they are in Visual Studio 2012. Okay, so you can definitely create those straight away. And I think everything else is just either targeting, it's either a Windows Store app project or it's a Windows Phone 8 app project. Yeah. Sure. Add. Oops. So I'm adding a new project. PCL is right here. I'll add it. And here you can see I can pick the frameworks that I want to target. So I can go to .NET 4 if I wanted to. I can hit Silverlight. I can do Windows Phone 7. I can even do Xbox. And so again, if you think about it, when you're targeting 3 screens in the cloud, if you build your app right now for Windows 8, Windows Phone 8, and one day, the Xbox opens up and becomes an open and viable platform, you're also able to kind of use these same patterns and practice to make sure your code is portable to the Xbox. Again, there'll be some wrenches and some new patterns, but it will be possible. Cool. So I think that's it. Any other questions? Yeah.
Do you have that source code somewhere?
Okay, so what I have is right now it's on my blog for Windows Phone 7.5 and also for the Windows 8. So that was the blog post I put up a couple months ago. And the code is down at the bottom. I actually use this exact same code, and I just automatically ported it to Windows Phone 8, and it compiled with an F5. There might have been one or two changes, but it works. But we will put this up, basically put this project up on my blog again. Cool? All right, thanks for coming, guys. Appreciate it. If you have any other questions, I'll be here for a little while. Cool?